Hello, this is Mr. Hanna. Welcome to What the Format. Today we are going to go over your base or parent absolute value function. Again, a reminder, you're going to see parent function on almost every textbook or online, but I prefer the term base. It makes more sense to me. This is an example of what I hope you guys are doing. You take the information given you, and if there's a way that makes it easier for you to understand it, you're adopting that. Okay? Base parent absolute value function. This is what it is. F of x equals the absolute value of x. Notice you're not doing anything to x except taking the absolute value. Okay, that's the way base function works. It's just one thing, nothing else. Now, if you do other things with it, add the bells and whistles, that's your transformed function. Well, what does transformed mean, Mr. Hanna? It means changed. It changes. What are your changes? Well, there's a few. First, you can take your graph, and usually an absolute value function is a V, like that. Okay, well, it's centered on 0, 0. That's your center point. Okay, makes a nice even line. But guess what I can do with that? I can reflect it. See that? That's when you have a negative in front. This is when you have a positive. Now, when you look at an absolute value function that's been changed, you'll have an A there or not. Could be 1, could be 2, negative 3, 5, different number. But if that number is negative, that means your graph, your V, instead of facing up, faces down. Now, a lot of places when they teach you about stretches and shrinks, vertical stretches, vertical shrinks, will deal with the absolute value of A. I find that a little confusing. So what I did is I separated the sign. So out here, right here, is your first transformation. It's negative, and that's a reflection across the x-axis. Now, that's if there's negatives there. The negative doesn't have to be there. That's the choice of whoever gives you the problem. If there's no negative, it doesn't reflect. It doesn't go down. Okay? That's something to keep in mind. Now, the A is your vertical stretch or shrink. What that means is the graph goes up or down, gets skinnier, fatter. Now, the way I like to think of it is this. If you put your hands together on something and you pull it up, like say some silly putty, it stretches up, okay? Leave this hand down, you stretch it up, okay? Now, if you push it back down, that's your shrink. Stretch, shrink. Now, what if it's negative? Then the stretch or shrink goes down. You stretch it down or you shrink it down, okay? So, A stretches or shrink it regardless of whether it's plus or minus. The difference is a positive stretches you or shrinks you up. A negative stretches or shrinks you down, all right? So, it's a stretch when A is bigger than 1. It's a shrink when A is less than 1. So let's say my A is negative 2. We don't look at the negative, remember? We only look at the 2. 2 is bigger than 1, so that's going to be a stretch. Now, because it's negative, it doesn't stretch up, it stretches down. The negative is what gives you reflection across the x-axis, then the 2 stretches you. Notice that I break that up into 2 parts. I don't like to do them together. I like to separate them. I consider the reflection a separate transformation. It's not always there, but there you go. Now, what do you have? Your H. Well, guess what? They call that your horizontal shift. That means you move the graph left to right. Now, something to note, okay? A plus H actually moves you left. A minus H moves you to the right. You're going to want to remember that. Then your K is your vertical shift, up or down. Plus K is up, minus K is down. Okay? You'll notice that the K follows the signs, the H does not. Now, why is that? Well, I'm going to have another video here momentarily that I'm actually going to do an example of an absolute value function that's been transformed. Okay? Now, word of caution on your transformations. You'll see textbooks and online, they try to tell you how to transform a linear function. Please don't ever do that. Okay? Here's why, in my opinion. You have a line, if it moves to the right, it also moves your center point down. So then it becomes difficult, in my mind at least, to see whether you went right or left or up or down. And because a line doesn't really have a shape, it's really kind of hard to tell what transformation happened. The V has a set shape, okay? You can see whether the V got stretched up or shrunk, okay? You can see that. You can also see if it went up or down. You can see the reflection. You can see that. So it makes seeing the transformations much easier. So you'll have some people, again, like I said, you'll run into this on some tester stuff. Just do the best you can with the transformation of lines, but the best place to start with transformations is absolute value functions. And then we apply it to all the other functions, because every other base function we do will have a set shape. If that set shape, once you've memorized it, changes. All right? Now this shape I did, that was for your exponential function, okay? Your U is for your quadratic function. Every function has a shape. Once you know that shape, then you'll be able to tell when it changed. And then this is your 4 basic transformations. Now there are a couple others. There's a horizontal stretch and shrink, also a reflection across the y-axis. However, if you look that up, you'll find a lot of times that isn't taught right or correctly, because the horizontal stretch or shrink actually does more than just horizontally stretch or shrink it. So what I try to do is I master these 4 first. Then if I have the horizontal stretch or shrink or the y-axis reflection, then I handle those separately. And I want you to start to think that way. You don't have to master all of math at once. You start with a piece at a time. Okay? Playing piano, you're not going to play Rachmaninoff right at the beginning. Sometimes not even right at the end because of how challenging it is. But you can build up to it. You can practice and practice and practice and get better and better and better after years and years. Then all of a sudden you start to play things that you never thought you could play. Math's the same way. Start with the basics. Play with them. Don't make it too hard, but on the easier problems, learn to think through them. Learn to identify each piece one at a time and know what it means. Okay? Does this take time? Yes. Does it take effort? Yes. Everything in life worth learning takes time and effort. Now, I know what a lot of people have said. I'm going to address that here right now. When am I ever going to use this in life, Mr. Hanna? Well, that's a good question. I don't know. Good chance that you'll never see this in your real life. But what you will see is learning in your real life. And learning has different symbols or words or processes that you have to master. If you master those, like say on a new job, then you keep your job. But what happens if your boss tries to teach you how to do something and you can't learn because you didn't practice in school? Okay? You're going to learn new jobs the same way you learn your math problems because your brain works a certain way. Once you figure out how your brain works and you practice absorbing and processing information, your brain's always going to absorb and process in that way. And you get stronger with it. Then you can learn anything. Okay? This is practice learning. That's what you're going to use. How you learn this is what's important. It's not what you're learning that's important, it's how you're learning. Now in this case, I'm focusing on math because I also want you, as you're learning, to do well in math, because that's going to give you confidence, it's going to feel good, right? I've seen that. When students realize, hey, I can do this, it really changes their attitude and their mindset. The problem with a lot of students now is they go in defeated. I can't do this. Well, no, you can't do it all at once. You have to take it a step at a time. Well, maybe you start by learning the negative ones and go and look at a lot of absolute value functions and learn to identify the negative. When you get good at that, now you look at the A, then you look at the H, then the K, and you do it a piece at a time. And then one day, all of a sudden it all comes together for you and it makes sense. I failed my first term of Algebra 1. Okay, I failed it. But that's because I didn't know what they were asking me to do. Once it clicked in Algebra 2, I've never had a problem since with math. But that's the thing is, I stuck with it. I didn't give up. Don't give up. Yes, I know this is a lot. But again, you have the video. You could rewind this, okay? You can make notes. And then when I do my other videos, you can compare those notes and you can start putting those things together. That's the purpose of this channel. I hope it's helping you. Thank you for watching What the Format. This is Mr. Hanna. Happy mathing.